imagine, for a moment, that you are drifting high above the western edge of Africa, looking down through thin clouds at a sea of pale gold sand. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. From this height, the Sahara stretches in every direction, a vast, quiet ocean of dunes and dry stone, broken here and there by dark ridges and faint, dry riverbeds. And then, almost without warning, your eye catches something that does not seem to belong. A circle. A great, soft, perfect circle, drawn into the desert floor as if by the steady hand of a giant. It is not just one circle, it is many, set inside one another, ring after ring, like ripples frozen in stone. The outer edge measures nearly 30 miles across. The whole shape is so wide that you cannot see it from the ground. Standing inside it, you would only see low ridges and gentle slopes and dry scrub, with no sense at all that you are walking across the floor of one of the strangest patterns on Earth. Only from far above, from the windows of orbiting spacecraft, does the full shape reveal itself. This is the Richat structure. Some people call it the Eye of the Sahara, because from orbit it really does look like a great unblinking eye, staring up at the sky from the dry heart of Mauritania. The colors are gentle and slow, pale green rings, bands of soft blue-gray, hints of rust and ochre and old bone. The center is slightly sunken, like the iris of an eye, surrounded by raised ridges of harder stone that have resisted the wind a little longer than the softer rock around them. In the morning sun, shadows pool inside the rings, deepening the pattern. At noon, the whole thing flattens into a pale ghost of itself. At evening it glows warm and rose-colored, holding the last light of the day in its long, quiet curves. And here is where the wondering begins. Because no one is entirely sure how this shape came to be. For a long time, when people first noticed it from above, the most natural guess was that something had fallen from the sky, a meteor, perhaps, traveling fast and hot, striking the desert long ago, and punching a great round crater into the ground. That guess felt right, because the circle is so very round. Nature, on this scale, rarely draws perfect curves. Mountains zigzag, coastlines wander, rivers wind. A clean ring nearly 30 miles wide felt like the kind of thing only a violent impact could carve. But when geologists looked more closely, the meteor idea began to soften. The rocks of the Richat structure do not show the kinds of shattered crystals you usually find at impact sites. The center is not a bowl, the way most craters are. So the question opened up again. If not an impact, then what? One leading idea today is that the eye is the worn-down stump of an ancient dome. A great blister of rock, pushed up slowly from below by deep forces, then eaten away over millions of years by wind and water, until only its layered insides remained, exposed in concentric rings, like the inside of a sliced onion. Another idea is that hot fluids deep in the earth helped shape the unusual minerals at the center. Other researchers have wondered about the role of long-vanished rivers, or about combinations of forces working together over enormous spans of time. None of these explanations are fully settled. Each one answers some questions and leaves others open. The roundness, in particular, is still a puzzle that quietly resists the simplest stories. For tonight, that is enough to hold in mind. A circle in the sand, so large that astronauts use it as a landmark when they pass overhead. A pattern, so striking that early space crews stared at it through their windows and wondered what it could possibly be. A place where the slow patience of the desert has uncovered something that we still cannot quite explain. In the sections to come, We will walk slowly through what the geologists have found, what the satellites have shown, and what the nomads who crossed this ground long before any of us have always known about the place. We will sit with the theories, one by one, and notice where they agree and where they part ways. For now, just hold the picture in your mind, the pale rings, the sleeping desert, the great quiet eye of the Sahara, staring up at the sky, keeping its secret a little longer. Let us begin with the simplest picture, the kind you might sketch on a napkin in a quiet kitchen out in the Western Sahara. In the country of Mauritania, the flat desert floor carries a shape that does not seem to belong there. From high above, it looks like a great pale eye opened in the sand, rings, inside rings, fading outward, almost perfectly round. Geologists call it the Richat structure. Many people simply call it the Eye of the Sahara. The eye sits in a region called Adrar, near a small town called Ouaddaine. Around it, the desert stretches in every direction. Low dunes, dry plains, scattered stones, and very little water. There are no tall mountains here to hide behind. There are no thick forests to break the view. The land is mostly flat and dry, which is part of why the rings stand out so clearly when seen from far above. The size is the first thing that surprises people. The outermost ring measures roughly 40 kilometers across, which is about 25 miles. If you tried to walk from one edge of the structure to the other in a straight line, it would take a long, slow day on foot. If you placed a large city inside the eye, the city would fit easily within the rings. Some of the biggest urban areas in the world could sit comfortably inside its outer boundary, with room to spare. That is the kind of scale we are talking about. Not a hill, not a crater you could photograph from a nearby ridge. A feature so large that, from the ground, it looks like ordinary desert in every direction. This is why the structure was not truly recognized for what it is until people went up into orbit. The first clear images came in the 1960s, during the early crewed space missions. Astronauts in low Earth orbit kept noticing the same strange bullseye in the Mauritanian desert. They photographed it, they reported it, and over the decades that followed, as more satellites mapped the planet, the eye became one of the most familiar landmarks on Earth. When viewed from above, pilots use it as a checkpoint. Astronauts on the International Space Station still point cameras at it as they pass overhead. The rings themselves are not painted lines or sand patterns. They are ridges of harder rock, standing slightly taller than the softer ground around them. Wind and rare rain have worn the softer layers down over a very long time. The tougher layers have stayed put, like the spines on a giant fingerprint pressed into the desert. The colors shift from pale cream to soft brown to deep dusty blue, depending on the mineral content and the angle of the light. From orbit, those subtle bands look almost like the layers in a sliced onion. The age of the rock is harder to picture. Some of the stone exposed inside the eye is around 600 million years old. A few layers may be older still. To put that in human terms, the rock at the center of the rings was already ancient before the first fish swam in Earth's oceans. It was already ancient before any plant grew on land. Dinosaurs would not appear for hundreds of millions of years after these stones first formed. We are looking at a feature carved from some of the oldest rock anywhere near the surface of the Sahara. The composition is a mix that geologists find unusual. There is quartzite, a very hard rock made from ancient sand. There is limestone, formed from the remains of tiny sea creatures from a time when shallow seas covered this region. There are igneous rocks, which once cooled from hot, melted material deep underground. And at the very center, there are strange minerals and rock types that hint at heat and pressure from far below. How all of these layers came to be arranged in such a tidy circular pattern is exactly the question this whole episode will sit with. For now, hold the simple picture: a flat desert, a pale circle 40 kilometers wide, rings of stone fading outward like ripples frozen in place, rocks, at the heart of it older than almost anything you can imagine, a shape large enough to swallow a city, hidden in plain sight for most of human history, only revealed in its full form when our eyes finally rose high enough above the earth to see it. The next sections will begin to ask how such a shape could come to be. The theories are many. The answers, even now, are not complete. To wonder how the Richat structure came to be, we have to step very far back in time. Not centuries, not millions of years. We have to walk back nearly 100 million years into a world that would feel utterly strange to us now. The land that is today the dry plain of central Mauritania was not yet a desert. The Sahara, as we know it, did not exist. Africa itself was still settling into its modern shape, slowly drifting apart from South America after the breakup of an older, larger landmass. In that distant time, deep below the surface, the Earth was busy. The crust of our planet is never truly still. It bends, it stretches, it cracks. And beneath the part of Africa where the eye now sits, something was rising. Slowly, over countless ages, a great bulge began to form in the rock. Think of a blanket, lifted gently from below by a hidden hand. The layers of stone, which had been laid down flat over hundreds of millions of years, began to dome upward. This much most geologists agree on. The Richat is built from very old rocks. Some of the layers at its center are more than 2 billion years old. Above them sit younger layers, stacked one on top of another like the pages of a slow, thick book. Each page was once mud or sand or the floor of a shallow sea. Each page hardened into stone and waited. What caused the bulge to rise is where the agreement begins to thin. One leading idea is that hot fluids and molten rock pushed upward from far below, lifting the layers without ever quite breaking through to the surface. In this view, the Richat was once a kind of blister on the skin of the Earth, not a true volcano, but a swollen place where deep heat tried and failed to escape. Small amounts of igneous rock born from melted material, do appear in and around the structure, which gives this idea some support. A competing view sees the lifting forces as more mechanical than volcanic. In this telling, the dome rose mostly because of pressure from below and movement within the crust itself, with heat playing a smaller role. The unusual minerals found at the center, in this version, came from hot fluids passing through cracks rather than from a large pool of magma. The difference sounds small. It is not. It changes how we picture the whole birth of the place. What everyone agrees on is what came next. Time. Enormous, patient time. Once the dome had risen, the forces of the surface went to work on it. Wind, rain, heat, cold. The Sahara was not always dry, and the region passed through many shifts of climate. During wetter ages, rivers ran across this land, and water cut into the raised stone. During drier ages, the wind took over, polishing and stripping the surface grain by grain. Because the dome was made of layers of different hardness, the erosion did not work evenly. Some layers were soft and gave way quickly. Others were tough, especially the quartzite, a pale, glassy rock that resists almost everything the weather can throw at it. As the softer layers wore down, the harder ones remained, standing as low ridges. The dome was, in effect, sliced from the top by the slow knife of time. What we see today is the inside of that vanished dome, peeled open and laid flat. The rings are not built up. They are what was left behind. This is the heart of the riddle. Geologists understand erosion. They understand domes. They understand layered rock. What they do not fully understand is why this particular dome eroded into rings so nearly circular, so cleanly arranged that astronauts could pick it out from orbit without instruments. Other eroded domes exist on Earth. None match the eye for tidy geometry. The shape suggests that the original uplift was unusually symmetrical, almost as if the rock had been pushed straight up by a perfectly round force from below. What that force was, and why it acted so evenly, remains an open question. So the origin story, as best we can tell, is a long, quiet collaboration. Deep heat and pressure raised the land. Wind and water lowered it again. Between them, across more than 100 million years, they carved a shape that nature rarely makes so plainly. The exact balance of those forces, and the reason the result is so perfectly round, still waits for a final answer. For tonight, it is enough to picture the slow lifting, the slow wearing away, and the patient hand of time at work in the silent stone. When the first geologists stood at the edge of the Richat structure, they looked down at a pattern so round and so wide that the mind reached for the simplest explanation. Something must have fallen from the sky, a great rock from space, plunging into the desert, punching a perfect circle into the bedrock. The idea felt natural. Craters are round, the eye is round. For a long time, the falling star was the leading guess. It was a reasonable place to start. Earth carries scars from many impacts. The iron that makes up the core of our planet was forged inside ancient stars, scattered into space when those stars died, and gathered again into the dust that built worlds. Some of that iron still arrives in the form of meteorites, small dark stones that streak through the sky and settle quietly into deserts and ice fields. Mauritania itself has produced famous meteorite finds, lonely fragments resting on pale sand. So the idea that one enormous piece had once struck this exact spot did not seem strange at all. If the eye had been born from an impact, the rocks at its center would carry certain fingerprints. Researchers know what to look for. They search for shocked quartz, tiny grains of crystal whose insides have been bent and cracked by sudden, brutal pressure. They search for a mineral called calcite, a dense form of silica that forms only when ordinary rock is squeezed harder than any earthly process can squeeze it. They search for tektites, small blobs of glass born when an impact melts the ground and flings it into the air. These are the calling cards of a fallen star. At the Richat, the calling cards never arrived. Teams crossed the rings with hammers and bags. They studied the quartzite ridges, the carbonate layers, the volcanic rocks tucked near the center. They found no shocked quartz. They found no calcite. They found no tektites scattered in the surrounding sand. The minerals at the heart of the eye told a different story, one of slow chemistry and patient water, not sudden violence from above. This was a quiet kind of disappointment, and also a quiet kind of wonder. The impact theory had been clean and simple. Letting it go meant accepting that something stranger had happened here, something without an obvious name. The materials inside the rings, when studied closely, turned out to be a careful record of Earth's own deep past. There is sandstone, made from grains of quartz, worn down by ancient rivers and pressed together over long ages. There is dolomite, a pale carbonate rock that often forms in warm, shallow seas. There is limestone, built from the bodies of tiny sea creatures that once drifted in waters now long vanished. There are dark bands of basalt and other volcanic stone, hinting at heat from below. There is a strange ring of rock called kimberlite, which sometimes carries diamonds up from far beneath the crust. Every one of these stones links to something far larger than the desert. The silica in the quartz traces back to the slow weathering of older mountains, themselves built from older rocks, themselves built from the cooling skin of a younger earth. The calcium in the limestone passed through the shells of ancient organisms, drawn from seawater whose chemistry was shaped by rain, by volcanoes, by the breathing of the early atmosphere. The carbon in those shells once drifted as gas in the sky. Some of it may have arrived long ago on comets, icy travelers that fell into a young planet and helped fill its first oceans. So even though no star fell here, the stones at the eye are still made of star stuff. The iron that tints some of the rings a soft rust color was cooked inside suns that lived and died before our solar system existed. The oxygen that binds those iron atoms into rust was breathed out by green plants and ancient algae. Over hundreds of millions of years, the water that carved the rings, and there must have been water, came from somewhere very far away in time, possibly from the comets, possibly from gases trapped in the planet's first hot mantle. The mystery then shifts. The eye was not made by a thing arriving. It was made by things rearranging. Something here lifted these layered rocks into a vast dome, and something else wore that dome down with extraordinary symmetry. What that something was exactly is the question the next chapters of the science try to answer. The fallen star theory rests gently aside now, set down like an old map that turned out to lead somewhere else. The real story, whatever it is, must be told by the rocks themselves. For a long time, the leading idea about the Richat structure was simple and elegant. It was thought to be a dome. Imagine a great blister of rock pushed up from below, slowly, over many millions of years. Then imagine the top of that blister worn away by wind and rain, leaving behind the perfect rings of its inner layers. It was a clean story. It made sense of the bullseye shape, and for decades, it was the story most textbooks told. But the dome that everyone imagined turned out to be a dome that never quite was. When geologists looked closer, the simple blister story began to soften at the edges. The rocks were tilted, yes, but not in the neat outward way a true dome would demand. The center did not sit higher than the rim. In fact, the whole formation lies on a remarkably flat plane. From the ground, you might walk right across it and barely notice you were inside something 30 miles wide. The dome, if there ever was one, has been almost entirely erased. So what shaped it then? What forces, working in the dark and the deep, pushed these layers into circles and then left them behind so cleanly? The honest answer is that we are still piecing it together, but we can talk about the forces that almost certainly played a part, even if their exact recipe remains open. The first force is pressure from below. Deep inside the earth, the rock is not the cold, hard stone we know at the surface. It is hot. It moves, slowly, like very thick honey, over spans of time too long for our minds to easily hold. When a pocket of hot, lighter rock rises toward the surface, it pushes the overlying layers upward. This is how many domes in the world are born. At the Richat, something like this likely happened long ago, perhaps around 100 million years back, when the supercontinent of Pangaea was breaking apart and the African crust was being stretched and warmed from beneath. The second force is heat. With the rising rock came hot fluids, water and gases carrying dissolved minerals. These fluids seeped through cracks and reshaped the stone they touched. At the heart of the Richat, geologists have found rocks that hint at this kind of hydrothermal cooking. Carbonates and unusual silica deposits suggest that warm, mineral-rich water once moved through the center, leaving its fingerprints behind. Some researchers wonder if this hydrothermal activity, more than any single dome uplift, is the real key to the structure's shape. The third force is gravity, working hand in hand with time. Once the layers were pushed up and chemically changed, gravity began its patient work. Softer rocks crumbled, harder rocks resisted. Wind carried away the loosened grains. Rain, when it came, carved channels and smoothed slopes. Over tens of millions of years, the buried layers were peeled back like the skin of an onion, one ring at a time. The harder bands of quartzite stood up as low ridges. The softer bands wore down into valleys. The result is the pattern we see today, a quiet record of what resists and what surrenders. And there is a fourth force, less obvious but no less real. It is the slow, steady flexing of the continent itself. Africa is not a still object. It tilts. It rises and sinks in broad, gentle waves over geologic time. The plain around the Richat has been lifted and lowered, again and again, exposing new surfaces to the wind. Each cycle of exposure deepens the rings a little more. What remains unresolved is how these forces balanced. Was the uplift sharp and short, or slow and long? Did the hydrothermal fluids arrive early, shaping the chemistry of the rock before the rings ever appeared? Or did they come later, settling into cracks that were already there? Was there once a true dome that has since been completely shaved away? Or was the bullseye always more subtle than that? Different teams of researchers weigh these questions differently. Each new study adds a thread, and yet the full pattern still escapes us. What we can say is that no single force built the Richat. It was a slow conversation between heat and pressure, between water and stone, between uplift and erasure. None of it was hurried, none of it announced itself. The rings emerged the way a face emerges from a slowly worn coin, quiet and unhurried, over a span of time that dwarfs every human story. And the dome that everyone once imagined, the simple blister of rising rock, is now best understood as a piece of the answer, not the whole of it. The rest, for now, belongs to the open question. Step out into the middle of the Richat structure, and at first you might not even notice that you are standing inside something extraordinary. The ground beneath your feet looks ordinary enough. Pale sand, broken rock, a few low ridges in the distance. The rings are so wide, so gently curved, that from the ground they hardly look like rings at all. They look like hills. They look like long, low walls of stone that wander off toward the horizon and never quite come back. That is the first thing to understand about the scale of this place. It is too big to see properly when you're inside it. You can only really see it from the sky. The outer edge of the structure stretches about 25 miles across. To picture that, imagine standing at one end of a city and trying to see the other end. You cannot. The curve of the earth itself begins to get in the way. If you placed the Richat structure on top of a major metropolitan area, it would swallow the entire downtown, the suburbs, the airports, and still have room left over for farmland on its edges. A person walking briskly across it would need most of a day, with no shade and no water and no clear path. Now think about the rings inside that outer edge. There are several of them, nested, one inside the other, each one a long ridge of harder stone, rising above softer rock that has worn away around it. The ridges themselves can stand a few hundred feet tall in places. That is the height of a 30-story building, and these stone walls curve for miles, smooth and patient, like the ripples that spread out when a pebble drops into a still pond, except frozen in rock and stretched across the desert. At the very center, there is a kind of bullseye, a flatter inner zone, roughly 2 or 3 miles across, small enough that you could, in theory, walk across it in an afternoon. But the rocks you would walk over there are the strangest part of the whole story. Those central rocks are old, genuinely deeply old. Geologists who have sampled them say some of the stone at the heart of the Richat structure formed more than 2 billion years ago. 2 billion. The number is so large that it slides off the mind. Try to hold it for a moment. If you compressed all of Earth's history into a single 24-hour day, those central rocks formed before lunchtime. Dinosaurs would not show up until well after dinner. The pyramids of Egypt would appear in the final fraction of the final second before midnight. The rocks at the center of the Richat are older than complex life. They are older than the oxygen in the air you are breathing right now. When they first cooled and hardened, the oceans of Earth were strange green broths, lit by a younger sun, populated by little more than mats of bacteria. No fish, no plants, no insects, just slow, quiet chemistry under a sky no human eye would ever see. And then, somehow, those ancient rocks ended up at the bullseye of a near-perfect circle in the Sahara. That is part of the mystery. Why are the oldest stones at the middle? One idea is that a great dome of rock was slowly pushed upward from below, and the topmost layers wore away first, exposing the older stone underneath. Another idea is that hot fluids deep in the crust altered the rocks in the center, leaving behind those unusual ancient minerals. The two ideas are not entirely separate, and neither one fully explains the geometry. The question stays open. It helps, sometimes, to compare the Richat to something familiar. Imagine an onion the size of a small country, sliced flat across the top. The outer layers are the youngest. The inner layers are older. The very core is the oldest of all. Now, imagine that someone or something peeled the top of that onion away so cleanly, so evenly, that from above you can read its age like the rings of a tree. That is more or less what the desert has done here, slowly over tens of millions of years. Wind, rare rain, heat, cold nights, tiny grains of sand carried on tiny breezes, polishing the stone one molecule at a time. The forces are gentle. The time scale is almost unimaginable, and the result is a shape so large, so old, and so quietly precise that we are still trying to understand exactly how it came to be. Hold that thought for a while. A bullseye of ancient rock, older than breath, wider than a city, waiting in the sand. Imagine standing at the edge of the rings on a still morning, the desert air already warming, the horizon faint and pale. The ground beneath your boots is not soft sand. It is hard, sun-baked rock, broken into flat plates and low ridges that curve away from you in long, gentle arcs. These arcs do not look natural at first. They look planned. They look swept. The arcs are made mostly of quartzite, a tough, glassy rock formed when ordinary sandstone is pressed and heated deep within the crust. Quartzite resists weather the way a hard ceramic dish resists scratching. The softer rocks around it have worn away faster, leaving the quartzite standing up in low walls and ridges. These ridges are the bones of the rings. They are what makes the eye visible from space, and what makes the pattern hold its shape across millions of years. Walking across one of these ridges, you would feel a faint crunch underfoot. The quartzite glitters in the low sun. Tiny grains catch the light like crushed glass scattered on a dark floor. The color shifts as the day moves. In early morning it looks pale pink, almost like skin. By midday it turns to bone white and tan. In the long evening it warms to honey and rust. The same stones, the same hour by hour, shift in mood. Between the hard ridges lie shallow valleys of softer rock. These are floored with smaller stones, broken shale, and a thin skin of wind-blown sand. The valleys are wide and flat, almost like dry moats curving around an old castle. If you walked across one, you might cross it in 10 minutes. Then you would climb a low ridge of quartzite, only a few meters high, and find another valley on the other side, then another ridge, then another valley. The pattern repeats again and again, drawing you slowly inward toward the center. From above, all of this reads as a series of clean concentric bands. From the ground, it reads as a slow, patient terrain, low, dry, and oddly quiet. There are no trees, there are almost no shrubs. A few hardy tufts of grass cling to the lee sides of stones. Lizards skitter across the warm rock and vanish into cracks. The wind moves grit in soft hissing waves. That hiss is often the only sound you would hear for hours. The layers themselves tell a story written in mineral. Each band of quartzite is the eroded edge of a once flat sheet of sedimentary rock. Long ago, these sheets sat stacked, one on top of the other, like the pages of a closed book. Something, and this is one of the open questions, tilted those pages upward into a dome. Then erosion shaved the top of the dome flat, slicing across the edges of every layer at once. What you see today on the desert floor is the cross-section of that vanished dome, exposed as if a giant knife had passed through it. That is why the rings look like rings. Each one is the outcrop of a different layer of rock, peeled back in turn. The oldest layers sit at the very center. The younger layers ring the outside, walking from the rim. Toward the heart of the eye, you are walking backward through deep time, stepping across rock that grew older with every ridge you cross. Mixed in with the quartzite, in places, are stranger stones. There are dark volcanic rocks here, in narrow ribbons and small mounds. There are odd, glassy fragments called breccias, which form when rocks are shattered and then welded back together by heat or pressure. There are carbonates, soft and pale, sometimes streaked with rust from old iron. Researchers have argued for decades about what these unusual materials mean. Some see them as fingerprints of slow underground fluids. Others see them as hints of an older, deeper process that has not yet been fully named. The surface holds these clues in plain view. But plain view here is enormous. The outer ring stretches more than 40 kilometers across. You cannot take in the whole structure with your eyes. You can only ever see a small slice, a single ridge, a single shallow valley, a single field of glittering quartzite. The pattern that defines the eye is not visible to anyone standing inside it. That, perhaps, is part of why the place feels so strange. You walk across one of the largest patterns on Earth, and from where you stand, it simply looks like more desert. The rings remain hidden in plain sight, waiting for the high view that only the sky can give. To stand near the eye of the Sahara today is to stand in a place that feels finished. The wind moves across the open ground in long, soft sweeps. The sand whispers against the stones. The sun warms the pale rock until the air above it shimmers. It feels like a place that has always been this dry, And yet, beneath your feet, the rocks remember a very different world. The layers that make up the Richat structure were not laid down in a desert. They were laid down in water. Long before the Sahara was sand, much of what is now Mauritania sat at the edge of warm, shallow seas. Tiny shells drifted down through the calm water. Mud settled in soft sheets on the seafloor. Layer by layer, over millions of years, these quiet sediments hardened into stone. When you look at the bright bands of the eye from above, you are looking at a slice through that ancient seabed. The rings are not paint, they are the upturned edges of old ocean layers. Each band marks a different chapter in the slow story of a vanished sea. The oldest rocks at the heart of the structure are far older still. They date back more than 2 billion years, to a time when the continents themselves wore different shapes. These deep stones formed when this part of Africa was joined to South America in a single great landmass. The two halves had not yet pulled apart. The Atlantic Ocean did not exist. The world map, if anyone had drawn it, would have looked like a stranger's face. Above those ancient roots lie younger rocks, but younger here still means very, very old. Some of the sandstone rings formed around 500 million years ago, when the first hard-shelled animals were just beginning to crawl across distant seafloors. The land where the eye now sits was likely warm and damp, swept by tides that have long since dried away. Then, somewhere in this long story, the layers began to lift. The ground rose slowly, as if a great breath were being drawn beneath the crust. The flat sheets of seabed bowed upward into a wide dome. We will sit longer with how this dome may have formed in later sections. For now, it is enough to know that the rings we see today are the worn-down stumps of something that once stood much taller. The sea was not the only world this place has known. After the dome rose and began to wear away, the climate kept changing. There were times when rivers ran across this region, fed by rains that no longer fall here. There were times when shallow lakes filled the low places. There were times when the land was green with grass and dotted with trees and animals. The Sahara, the great dry sea of sand we picture today, is a fairly recent face for this corner of the world. Some researchers believe the Sahara has swung between wet and dry many times across the last few million years. The wet periods last for thousands of years. The dry periods last for thousands more. The eye has watched all of them pass. Its rings have been splashed by river water, dusted by pollen, and then bleached again by the desert sun. Beneath the surface, the story grows even quieter and stranger. Geologists who have drilled and mapped the area find old fractures running deep into the crust. They find traces of hot fluids that once moved through the rock, leaving behind strange minerals in cracks and pockets. They find evidence that the deep stone here has been squeezed, heated, and slowly cooled more than once. The question of what truly happened in those depths remains open. One idea is that magma rose from far below and gently lifted the layers without ever breaking through. Another idea is that the lifting came from forces farther away, from the slow movement of whole continents pulling and pressing on this corner of Africa. Both ideas leave room for doubt. Both leave parts of the puzzle unexplained, and both remind us that the surface of the eye, with its calm bands of pale and rust-colored stone, is only the topmost page of a much longer book. When you picture the Sahara now, try to picture it in reverse. Picture the sand lifting away. Picture rivers winding back through the dust. Picture grasslands, then shallow lakes, then warm seas, then ancient stone domes, then deeper roots older than almost anything on earth. The eye does not only stare upward at the sky, it stares downward into time, and it holds many secrets it has not yet shared. The desert around the eye does not look like a place where rivers once ran. The sand stretches flat and dry. The wind moves slowly across the rocks, and the silence feels old, yet the ground itself remembers water. If you walk the plain around the rings, you can find pale stones rounded by ancient currents. You can find layers of sediment that only settle at the bottom of lakes. You can find faint channels traced into the bedrock, soft curves that no wind could carve. The Sahara, in its long and patient memory, has not always been a desert. The story of the eye is also the story of these vanished waters. Earth itself breathes in slow cycles. The planet's tilt shifts a little. Its orbit stretches and rounds, and the path of sunlight across the continents drifts over thousands of years. These slow rhythms are called Milankovitch cycles, named for the scientist who first worked them out, and they help decide which parts of the world get rain and which do not. When the rhythms align in a certain way, the African monsoon reaches farther north than it does today. Rain falls where now there is only dust. Lakes appear, grasses spread, animals follow. This is what happened during the African humid period, a long wet chapter that ran roughly from 11,000 to 5,000 years ago. The Sahara turned green. Hippos waded in shallow lakes. Crocodiles sunned themselves on muddy banks. Herds of cattle, kept by early pastoral people, drifted across what is now bare stone. The eye sat at the heart of this softer world, and water moved across its rings. You can still see the ghosts of those waters in satellite images. Pale braids of old riverbeds wind across the plain, fanning out from higher ground and curving around the structure. Some of these channels cut into the outer rings. Others drain toward the center, where the ground dips slightly. Geologists call these dry channels wadis, a word from Arabic for valleys carved by water that no longer flows. The Sahara is laced with thousands of them, quiet veins of a body that once breathed differently. How exactly the rivers interacted with the eye is still a question with several answers. One idea is that the central basin held a shallow lake during the wet periods, a calm mirror of water ringed by stone. Sediments found in the middle of the structure hint at standing water at certain times. Another idea is that the eye was never a lake at all, but a place where streams gathered briefly and then drained away through cracks in the bedrock. The evidence is patchy, and the two pictures may both be partly true at different moments in the long cycle. Older waters left deeper marks. Long before the humid period, in epochs measured in millions rather than thousands of years, larger rivers may have crossed this region when the climate was wetter still. Some researchers have proposed that an ancient drainage system, sometimes called the Tamanrasset Paleoriver, once ran westward across the Sahara toward the Atlantic. Whether its branches touched the area of the eye is not certain. The shifting sands have covered most of the older channels, and what remains lies buried beneath dunes that move with every storm. The cycles continue. Though we live in a dry chapter, the Sahara is not permanent. In another 20,000 years, give or take, the slow tilt of Earth's axis may once again bring the monsoon further north. Rain may return to the plain around the eye. Grasses may rise. Small pools may form in the lower rings, catching the morning light. No one alive will see it, but the rock will, in its patient way. For now, the desert holds the memory quietly. Pebbles polished by water sit on dry stone. The remains of freshwater snails turn up in the dust far from any pond. Stone tools left by people who once fished and herded here rest where their owners dropped them, untouched by the centuries. The eye does not announce these things, it simply contains them, layer beneath layer, as it has contained the rise and fall of so many climates. What the rivers actually did to shape the rings is still being worked out. Did the flowing water carve the concentric pattern deeper, accenting the soft layers and leaving the hard ones standing? Or did the rings already exist in their strange near-circular form, and the rivers simply trace their grooves for a while before drying up? The answer probably lies somewhere between the two, written in sediment cores that have not yet been read. The eye keeps its rhythms slow, and we are only beginning to learn how to listen. Nothing in the desert stands truly alone. The eye of the Sahara sits in a wider neighborhood of stone and sand, and that neighborhood has shaped it just as much as any deep force from below. To understand the rings, it helps to step back and look at what surrounds them. The land here is called the Adrar Plateau, a broad shelf of pale rock in the heart of Mauritania. It stretches for hundreds of miles, flat in some places, broken by low cliffs in others. The plateau is old. Some of its rocks were laid down more than 500 million years ago, when shallow seas covered this part of Africa. Across that plateau, wind and rain have been at work for an unimaginably long time. The work is slow. It is the slow breath of erosion. Each year, the desert wind lifts a thin veil of sand and carries it somewhere else. Each rare rainfall loosens a few grains of stone and washes them into a dry channel. Multiply those tiny losses by millions of years, and whole mountains fade away. The Richat structure is what is left after that slow breathing has gone on for ages. It is not a thing that was built. It is a thing that was uncovered. The neighboring rocks tell the same story. To the east, low ridges of sandstone rise above the plain, their edges softened by the same wind. To the north, dark cliffs mark the boundary of older formations. To the south, the land slopes gently toward the Senegal River basin, where the desert eventually gives way to dry grasslands. The eye is not a lonely freak in the middle of nowhere. It is one feature among many in a region that has been worn down, layer by layer, for hundreds of millions of years. What makes the Richat unusual is not that it eroded, but how evenly it eroded. The rings stand out because the softer layers of rock between them have been carved away more quickly than the harder layers. Quartzite, a tough rock made of fused sand grains, resists the wind. Softer shales and limestones give in. Where these layers were bent into a dome long ago, erosion has shaved off the top and exposed the edges of each layer as a ring. The neighboring plateau, by contrast, has flat layers, so it erodes flat. The eye is a window into what the surrounding land would look like if you could slice it open and peer inside. The climate around the structure also matters. The Sahara today is one of the driest places on Earth. But the desert has not always been a desert. During wetter periods, rivers cut across this region, and those rivers helped sculpt the rings we see now. Old channels can still be traced in satellite images, running near the structure and sometimes through it. When the rains returned, water gathered in the low ground between the rings and slowly deepened them. When the rains left, the wind took over again. The eye has lived through many of these swings, and each swing left a small mark. There are other circular features in the wider region, though none as striking. Some are smaller domes that erosion has half exposed. Some are shallow basins where softer rock has been scooped out. Geologists study these neighbors to learn how the Richat fits into the family. If similar processes built similar shapes nearby, that supports the idea that the eye is part of a broader pattern of slow uplift and patient wearing down. If the Richat truly has no close cousins, then something more unusual may have happened here. The evidence on that point is still being gathered. The living neighbors are sparse, A few hardy shrubs cling to the cracks between stones. Small lizards dart across the bright sand. In the cooler months, nomadic herders sometimes pass through with their camels, following old routes that have been used for centuries. The town of Wardain lies not far away, an ancient trading post whose mud brick walls have themselves been slowly eroded by the same desert winds. Human life here is shaped by the same slow forces that shape the rock. Standing at the edge of the structure, you would not see the rings. You would see only a low rise, some pale cliffs, and the endless horizon. The pattern only appears from far above. That is one of the quiet wonders of this place. The eye is woven into its surroundings so completely that, from the ground, it almost disappears. Only from orbit does the family resemblance fade, and the strangeness of the Richat begin to show itself again, waiting patiently for the next question. Step back for a moment and consider the sheer strangeness of the setting. The Richat structure does not sit in a place of mountains or canyons or dramatic relief. It sits on one of the flattest, most featureless stretches of desert on the planet. The land around it is a vast tabletop of pale stone and sand, stretching for hundreds of miles in every direction. There are no peaks to frame it. There are no valleys to give it shadow. And in the middle of all that flatness, the desert holds a near-perfect circle, nearly 30 miles across. That contrast is part of what makes the structure feel so extreme. Most large geological features announce themselves with height. A volcano rises, a canyon falls, a mountain range buckles the horizon. The Richat does none of these things. From the ground, you would barely know it was there. The rings rise only a few hundred feet above the surrounding plain. At their tallest points, a walker crossing one of the ridges might think they had simply stepped onto a low, curving hill. The full pattern only reveals itself from far above. This makes it one of the largest landforms on Earth that is essentially invisible at human scale. You can stand inside it and not see it. You can drive across it and not know you have passed through 3 rings. To truly see the eye, you need altitude. You need an airplane, a satellite, or the window of a spacecraft. Few features in the natural world require that much distance to be understood. The age of the rocks at the heart of the structure is another extreme worth pausing on. The oldest stones exposed in the central area date back more than 2 billion years. That is roughly half the age of the Earth itself. These rocks formed long before any animal walked the planet. They formed before plants existed. They formed in a world whose continents had not yet taken their modern shape, whose atmosphere was still slowly filling with oxygen, whose oceans held only the simplest forms of life. To stand on those stones today is to stand on a fragment of a planet that almost no living thing has ever seen. The Richat also holds one of the cleanest examples of near-circular geometry at this scale anywhere on land. Most large round features on Earth are impact craters, and most impact craters are not as round as people imagine. They are often oval, distorted, or worn into rough shapes by time. The Richat's rings, by contrast, trace curves so smooth that early observers were certain they had to be the scar of a giant meteorite. The roundness felt too precise to be the work of slow geological forces. And yet, as later studies suggested, slow geological forces may indeed have shaped it. How those forces produce such symmetry remains one of the open questions of the site. The temperatures here belong to the extremes as well. Summer surface temperatures on the dark inner rocks can climb past 140 degrees Fahrenheit. Winter nights can drop to near freezing. The daily swing is huge. Wind scours the plain almost constantly, lifting fine dust into the dry air and polishing the exposed stone over centuries. Rainfall is rare. In some years, almost none falls at all. The structure sits in one of the driest stretches of the Sahara, far from any coast, far from any reliable source of water. Any life that survives here does so on very thin margins. The scale of erosion required to expose the rings is its own quiet record. Geologists estimate that several thousand feet of overlying rock have been stripped away above the Richat over many millions of years. The wind, the rare floods, the slow chemistry of heat and frost have carried away an unimaginable volume of stone. What we see today is essentially the cross-section of something that was once buried deep. The eye is a wound that time has opened slowly, layer by layer, until the inner anatomy of the land lay bare to the sky. And still, with all these extremes catalogued, the age, the flatness, the symmetry, the depth of erosion, the harshness of the climate, the central question stays open. The records the structure holds do not, on their own, explain how it formed. They only sharpen the puzzle, a nearly perfect circle on a nearly perfect plane, carved from some of the oldest rocks on the continent, by forces we still cannot fully name. Each extreme adds another constraint to the riddle. None of them, by itself, solves it. The eye remains what it has always been to anyone who studies it closely, an outlier among outliers, watching the desert from the desert floor. From far above, the eye of the Sahara does not look like one color. It looks like many. The rings shift from pale cream to soft rust, from gentle gray to a quiet, almost bluish shadow, where the rock catches the light just so. Each band of color is a different layer of stone, exposed by millions of years of patient wind and weather, and each color carries a small clue about what the desert was, long before it was a desert at all. The lightest rings, the ones that gleam almost white in satellite images, are made mostly of pale sandstone and quartzite. Quartzite is a hard rock, born when sandstone is squeezed and heated deep inside the earth until its grains lock together. It resists erosion, so while softer rocks around it crumble away, the quartzite stands a little taller, forming the raised ridges that give the eye its bullseye look from orbit. From the ground, those ridges are low, gentle rises. From space, they are perfect circles drawn in chalk. Between the pale rings lie darker bands. These are softer rocks, often shales and weathered sediments, ground down by the wind into low, flat plains. They hold the color of old iron, of rust and earth and dried tea. In some places, they shade toward a deep, warm orange. In others, they fade to a tired brown. The contrast between the hard, pale rings and the soft, dark valleys is what gives the structure its strange, drawn-on-paper clarity. At the very center, the colors change again. Here, geologists have found something unusual. A patch of rock called a breccia, made of broken fragments cemented back together, sits near the middle of the eye. It often appears in a slightly different shade, sometimes greenish, sometimes darker than the surrounding stone. The breccia contains tiny crystals that hint at hot, mineral-rich water moving through the rock long ago. One theory holds that this water rose from deep below, carrying dissolved minerals up into the cracks. Another suggests the breccia formed when overlying rocks collapsed and shattered as the dome above them gave way. Both ideas remain on the table. Among the smallest wonders of the eye are its little black specks. Scattered across parts of the central rings are pieces of volcanic rock, dark and glassy, the remains of ancient molten flows that never quite reached the surface. Up close, some of these rocks glitter faintly with tiny crystals. From orbit, they are invisible. From a few meters away, they look like ordinary dark stones. Under a microscope, they reveal the slow, patient chemistry of a planet that once cooked something strange beneath this exact patch of sand. Wind has its own gentle art here. Across the rings, the sand has been sorted by countless years of moving air. In some places, the grains are coarse and pale, almost gravelly. In other places, the sand is finer, almost powdery, the color of soft honey. Where the wind slows, it drops the heavier grains. Where the wind quickens, it lifts the lighter ones and carries them on. The result is a kind of natural painting, with color bands inside the color bands, smaller patterns nested within the bigger ones. Look closer still, and you find the work of water, even in this dry place. Faint channels run between the ridges, the dry tracks of seasonal rains that fall rarely, but heavily. These channels carry pale streaks of sediment outward from the center, like spokes on a wheel that is mostly invisible from below. Satellites pick them out easily. A person standing on the ground would barely notice them. The colors also shift with the time of day. At dawn, the rings glow pink and gold, the long shadows turning every ridge into a soft, sculpted line. At midday, the contrast flattens, and the structure almost disappears into the bright, washed-out desert. At sunset, the rust tones deepen until the whole formation looks like the last embers of a great, slow fire. From orbit at night, it vanishes entirely into the dark. What scientists find quietly beautiful is how much information sits inside these colors. Each band is a chapter of Earth history written in mineral and dust. The pale rings whisper of ancient seas and sandy shores. The dark valleys speak of muds that settled in quiet waters. The central breccia hints at heat and pressure from below. And yet, when you stitch all those chapters together, the story still does not fully explain the perfect circular shape. The colors describe the layers. The geometry remains the open question, waiting underneath. Long before satellites turned their patient eyes toward the desert, the rings of the Richat structure were already there, waiting. They were waiting under the feet of nomads who crossed the plain for centuries. They were waiting under the wheels of the first cars that bumped across the gravel in the early 20th century. The strange thing about this enormous shape is that, from the ground, it hides in plain sight. A person standing on one of its ridges sees only another low ridge. Much like the others, the pattern is too large for a human eye to grasp. So the story of its discovery is really the story of slowly stepping back, again and again, until the whole picture came into view. The first written notes about the rocks of this region came from French geologists working in colonial Mauritania in the early 1900s. They were not looking for a giant circle. They were mapping the long, thin ridges of the Adrar Plateau, charting the layers of stone for use in road building and water surveys. Their notebooks describe quartzite outcrops, sandstone benches, and the strange way certain ridges curved back on themselves. One ridge would arc gently to the east. Another, miles away, would arc gently to the west. On paper, the curves seemed unrelated. On the ground, they seemed like ordinary hills. The pieces did not fit together because no one yet had the height to see how they fit. A geologist named Théodore Monod spent decades crossing the Sahara on camel and on foot. He was patient, careful, and fond of the long view. He recorded fossils, ancient tools, and the slow shapes of weathered stone. He passed near the rings more than once. He noted the unusual rock arrangements. Yet even Monod, with his deep knowledge of the desert, did not draw the full circle. The terrain was simply too vast. A single human walking the rings might spend a week tracing one curve and never realized the curve closed on itself. The truth began to take shape only when humans learned to fly. Early aerial photographs, taken by French military surveyors in the 1930s and 1940s, captured strange swirls in the desert floor. The photographs were grainy and partial. They showed arcs that looked too tidy to be natural, but the images covered only narrow strips of land. Pilots noticed the curves and mentioned them, but no one yet had a full overhead view. That view came from above the sky. In 1965, the astronauts of the Gemini program looked down from their small capsule and saw something the ground crews of a generation had missed. A great bullseye of pale stone stared back at them from the western Sahara. They photographed it. They puzzled over it. Later missions, including Apollo and Skylab, returned for better pictures. From hundreds of miles up, the rings were perfectly obvious. The shape that had taken a century of footwork to sketch was visible in a single glance from orbit. This is the quiet lesson of the Richat structure. Some mysteries are hidden not by depth, but by size. The rings were never buried. They were never lost. They were simply too big to be seen by anyone standing inside them. The stones had been fitting together the whole time. The geologists had been holding the puzzle pieces in their hands, without realizing the pieces formed a circle. Once, the orbital photographs reached scientific journals. A wave of new fieldwork began. Geologists arrived with cameras, drills, and notebooks. They walked the ridges again, but now with the satellite map open beside them. Things they had once dismissed as random outcrops now revealed themselves as parts of a single, organized pattern. A layer of quartzite on one side of the structure matched almost exactly a layer of quartzite on the opposite side, 20 miles away. The pieces of the puzzle suddenly snapped together. Even now, the structure resists easy answers. Each visit raises as many questions as it settles. The dome collapse idea fits much of the rock evidence. The hydrothermal idea explains some of the minerals. Neither explains the near-perfect circularity. Researchers continue to drill small cores, gather samples, and walk the same ridges that Monod walked. They carry better instruments now. They carry satellite data, magnetic surveys, and chemical tests. Yet the central question of how the rings came to be so round, so even, and so precisely nested remains stubbornly open. The history of discovery here is a reminder that the Earth keeps its secrets in many ways. Some it hides in the deep ocean, some it hides in the dark of a cave, and some, like the Great Eye of Mauritania, it hides simply by being too vast for a single pair of eyes to see. There is something strange about heat in the eye of the Sahara. When you look at the place from above, you see only dry, pale stone baking under the sun. The sand is hot. The wind is hot. The rings seem to shimmer in the afternoon light. Yet the real question of heat at the Richat structure is not about the sun overhead. It is about what may have once risen from below. Most people assume the rings were carved by water and wind alone. They picture rain wearing down soft layers over many ages, leaving the harder rock behind. That is part of the story, but it is not the whole story. Somewhere in the deep past, before the desert ever existed, hot fluids may have moved through the rocks of the eye, and those fluids may have left clues that still puzzle geologists today. When researchers walked the central rings in the early years of careful study, they found minerals that do not usually form at the cool surface of the Earth. They found carbonatites, which are rare rocks born from very hot, very strange melts deep underground. They found hydrothermal deposits, meaning rocks changed by hot water flowing through cracks long ago. They found traces of fluids that once carried metals and salts up from below. These small clues do not match the simple picture of a dry, wind-worn dome. They hint at a buried warmth. This is where the surprise begins. The Sahara feels like one of the most stable, sleepy parts of the planet. The land has not folded into mountains in a very long time. There are no smoking volcanoes nearby, no steaming vents in the sand. From the surface, the eye looks geologically quiet, yet the chemistry of its rocks suggests a far more restless past. Long before the first human walked across this plain, something deep underneath was warm enough to push fluids upward through the stone. One idea is that a slow rise of magma, molten rock from far below, once pressed against the crust here. It did not break through, it did not erupt. It simply lifted the layers above it, like a hand pushing gently from beneath a tablecloth. As the heat rose, hot fluids escaped through tiny fractures. They cooked the surrounding rock. They left behind unusual minerals. Then, over many ages, that buried heat faded away. The land slowly relaxed. Wind and water did the rest, exposing the rings we see today. A competing view says the heat was less dramatic. In this telling, the hydrothermal fluids came from circulating groundwater that was warmed by ordinary buried rock, not by any pulse of magma at all. Hot water can travel surprisingly far through cracks, picking up minerals along the way. Given enough time, even mild warmth deep in the earth can leave chemical signatures in the rocks above. Under this view, the eye is the result of patient, low-key processes, not a hidden flare of underground fire. The strange part is that both stories require something most observers would never guess from looking at the surface. They both require that this calm, sun-bleached patch of desert was once a place where heat and fluids moved quietly through the bones of the earth. The flatness of the modern plain hides that history almost completely. You could walk across the central rings and feel only the warmth of the sun on your neck. You would never sense the older warmth, the deeper one, frozen now into the chemistry of stones. There are other surprises tied to this question. The rocks at the eye are extremely old, some of them stretching back well over 1 billion years. That is far older than the desert itself. It is older than most of the mountain ranges still standing on the planet. The fluids that altered them moved through stone that was already ancient when they arrived. Whatever event warmed this place happened in deep time, in a world we cannot easily picture. There were no grasses then, no flowers, no animals walking the land, just bare rock, slow seas elsewhere, and the long patient work of the planet shaping itself. What remains unresolved is the source of that hidden heat. Was it a true magmatic pulse that nearly became a volcano and then thought better of it? Was it only warm groundwater, patiently doing chemistry over ages? Was it some mixture of both, layered across different times? The minerals tell us heat was here. They do not tell us with any certainty where it came from or exactly when it left there. And so the eye keeps another secret, tucked beneath its rings, waiting in the silence of the desert for someone to one day understand it. Beneath the still surface of the eye, in the deep rock that no eye can see, there is a story written in heat. The Richat structure does not stand alone in the history of the Earth. It is part of a much larger conversation that the planet has been having with itself for hundreds of millions of years. To understand the rings, we have to think about what was happening far below them, in the slow furnace of the crust and the mantle. Long ago, when the supercontinent Pangaea began to split apart, the land that would one day become West Africa felt a great pulling. The crust stretched. Hot rock rose from below. In many places along this stretching zone, magma pushed upward and shaped the ground from beneath. Some of that magma broke through and formed volcanoes. Some of it never reached the surface. It cooled in place, deep inside the crust, and left strange swellings of stone hidden under the sand. Many geologists think the Richat structure carries the fingerprints of this old pulling and pushing. The rocks at the center include igneous material, that is, rock born from once melted stone. There are rings of volcanic rock called kimberlite and carbonatite, which form only when very deep parts of the earth send up unusual blends of minerals. These rings are not loud. They are quiet bands in the stone that hint at a hot past. Yet no one has found the cone of an ancient volcano here. No one has found a clear crater rim. The volcanic whispers are present, but the volcano itself, if there ever was one, seems to be missing. This is where the eye connects to a much larger family of features around the planet. In several places on Earth, deep magma has pushed up under layered rock without ever breaking through. The land bulges upward in a great dome. Then, over tens of millions of years, wind and water peel the dome away from the top down. What is left behind is a circular pattern of rings. Because the layers of rock were curved like the layers of an onion, the Richat may be one of the grandest examples of this slow process. Or it may be something stranger. The question stays open. The connections do not stop with deep heat. The desert sky above the rings is also part of the story. The Sahara has not always been a sea of sand. It has shifted between green and dry many times, driven by slow changes in how the earth tilts and wobbles on its axis. These changes shift the path of the rains. When the rains came, rivers ran across this land. They cut into the soft outer layers of the dome and carried sediment away. When the rains left, the wind took over, polishing the harder quartzite ridges and lowering the softer rock between them. Heat from below built the shape. Climate from above carved it. The ocean, too, plays a quiet role in this symphony. Ancient seas once covered parts of what is now the Western Sahara. They laid down beds of sandstone and limestone that later became the layered cake of rock the dome would push upward. Without those flat, even layers, there would be no neat rings to admire from orbit. The ocean wrote the pages. The deep heat lifted them. The wind read them and tore them, one by one, until the pattern emerged. Even the slow drift of continents matters here. Africa has been moving north for a long time, pressing against Europe. That movement squeezes and stretches the crust in distant ways. Some researchers wonder whether old stress lines, from the breakup of Pangaea or from later collisions, helped guide the circular shape. Others think the geometry comes mostly from the dome itself, with the layered rocks dictating the curve. Both ideas may be partly right. Neither has been fully proven. There are competing voices in this chorus. One view sees the eye as a calm story of uplift and erosion, with magma as a side character that never quite stole the scene. Another view gives the deep heat a leading role, arguing that hydrothermal fluids, hot water rich in minerals, shaped much of the central rock. A third view, harder to test, wonders whether some combination of forces we have not yet named came together here in a way that is rare on Earth. What feels certain is that no single force made the eye. The sun warmed the air that drove the winds. The winds carried the sand. The rains carved the channels. The mantle pushed from below. The ocean wrote the layers long before any of this began. The rings are a meeting place of many slow systems, and we are still learning the words of their long, quiet conversation. For many years, when people first saw photographs of the Richat structure from orbit, the most natural guess was that something had fallen from the sky. A circle this round, this clean, this strange. It felt like the mark of an impact, a meteorite perhaps. slamming into the desert long ago, leaving behind a vast crater that wind and time slowly carved into rings. The idea is satisfying. It explains the shape in a single sentence, and for a while, it was the leading hypothesis among the scientists who studied the site from afar. But the desert had a different story to tell as geologists began to visit the structure on the ground, walking across the rings and chipping samples from the exposed rock. They searched carefully for the signatures an impact always leaves behind. Those signatures are well known. A meteorite strike creates enormous pressure and heat in an instant. The rocks at the point of impact get squeezed so hard that their tiny crystals deform in unusual ways. Quartz grains develop fine lines inside them, called shock lamellae, that only form under that kind of sudden violence. Certain minerals only appear when normal rock has been pressed harder than anything natural on Earth can press it, and often melted droplets of rock, called tektites, are flung outward and cool into glass as they fall. At Richat, none of these signatures have been found. The quartz grains in the rings look ordinary. The minerals tell a story of slow change, not sudden shock. There is no ring of melted glass scattered across the surrounding desert. There is no buried layer of shattered rock pointing back to a single moment of disaster. Everything that would normally shout impact is quietly absent. This absence changed everything. Slowly, through the second half of the 20th century, geologists let go of the meteorite idea. They began to look instead at the slow forces beneath the ground. The rings, they realized, were not the wound of a single moment. They were the result of patient transformation over a span of time so long it is hard to picture. Hundreds of millions of years, layers of rock pushed gently upward, then worn down at different rates, until what was once a buried dome became a flat target carved into the sand. The change in thinking happened slowly, the way most changes in science do. There was no single discovery, no triumphant announcement, just a steady accumulation of small observations. A field team would return with samples. A laboratory would test them. A paper would appear in a quiet journal, noting that the expected shock minerals had not been found. Another team would map the rings and notice that the layers tilted in ways more consistent with uplift than with collision. Year by year, the impact idea faded. By the early 2000s, most geologists had set it aside entirely, and yet the Earth itself keeps changing the structure even now as we speak of it. The desert wind never rests. Each year, a thin film of sand shifts across the rings. Grains of quartzite, harder than the surrounding rock, stand up as low ridges, while the softer layers wear away faster. The ridges grow more pronounced over centuries, even as the whole structure grows slightly flatter overall. The rings we see today are not exactly the rings someone might have seen 10,000 years ago, when the Sahara was green and rivers ran through this part of Mauritania. They are not the rings someone will see 10,000 years from now. The shape is permanent in our human sense. In geological time, it is in motion. There is something quietly humbling about this. The mystery has changed, even as we have tried to solve it. The impact theory rose, lived for decades, and then dissolved into the desert like a footprint. New theories have taken its place, and those theories too may one day be set aside as the evidence shifts. The dome collapse idea is the leading explanation today. The hydrothermal idea sits beside it. Some researchers wonder about combinations of the two. The conversation keeps moving. What remains is the shape itself, almost 40 kilometers across, lying patient on the plain. It does not care which theory is fashionable. It simply continues its slow work of being eroded, ring by ring, grain by grain. The wind lifts a single particle of sand from one ridge tonight and lays it down somewhere else. Multiply that by 1 billion grains, by 1 million years, and you begin to sense how the eye of the Sahara came to look the way it does. Not from a sudden blow, from an immense, unhurried patience that no human lifetime can quite hold. There is a soft hour in the Sahara, just before the sun lifts above the horizon, when the whole desert seems to hold a single color. The sand turns the pale pink of the inside of a shell. The rocks glow a deep rusty orange. The sky above goes from violet to gold in slow, quiet bands, and the great rings of the Richard structure catch this light in a way that is hard to forget. From the air, the outer ridges throw long shadows across the inner basin. The lower rings stay dark, while the high ridges shine. For a few minutes, the whole formation looks like a slowly turning wheel of color, lit from one side, asleep on the other. It is in this kind of light that the imagination begins to wander. And of all the places it has wandered, none has wandered farther than the story of Atlantis. The old tale comes from a writer named Plato, who lived more than 2,000 years ago. He described a great circular city, lost beneath the sea, ringed by walls of water and stone. The city, he wrote, had bands of land and water set inside one another, like the rings of a target. It sat on a wide plain, near mountains, near the ocean, and it sank in a single, terrible day. Plato never said where to look. He may not have meant the place to be real at all. Many scholars believe the story was a teaching tale, a way of warning his students about pride. Still, the rings of the Richat structure are circular. They sit on a wide, flat plain. They are not far from the Atlantic coast. And when a person looks at the formation from above, in that soft early light, the shape of Plato's city seems to rise out of the sand. Over the past few decades, some writers and amateur explorers have argued that this could be the lost city, dried out by time, buried by the slow march of the desert. Geologists, gently and patiently, point out the problems. The Richat structure is far too large to be a city. The outer ring stretches across roughly 40 kilometers, far bigger than any settlement Plato described. The rocks at its center are hundreds of millions of years old, shaped long before any human walked the earth. There are no walls, no harbors, no carved stones suggesting buildings. The rings are made of natural quartzite and limestone, worn by wind and water across deep time, and the site sits well above sea level, on a high plain, not on a coast that could sink beneath waves. The competing view, then, is the calm one held by most Earth scientists. The Richat structure is a beautiful coincidence of geometry, not the trace of a lost civilization. Its circles, formed from the slow doming and erosion of layered rock, a process that needs no human hand. The mystery here is geological, not mythical, and yet the pull of the Atlantis idea tells us something interesting about ourselves. The human mind loves a pattern. When we see a near-perfect circle on a flat brown plain, something in us asks who drew it. We are creatures of meaning. We look at clouds and find faces. We look at deserts and find cities. The Richat structure, seen in that low slanting morning light, gives the imagination something almost too clean to resist. This is part of why the formation has drawn so much attention from outside the world of geology. Books have been written about it, long videos have been made, maps have been drawn with hopeful arrows pointing toward its center. Some of these ideas have wandered very far indeed, into theories about ancient lost technologies and forgotten oceans. Most of them are not supported by the evidence in the rocks. But the open question, the real one, is not whether Atlantis sleeps beneath the sand. The real question is why this particular place, of all the strange places on Earth, has gathered so many stories. Perhaps it is the scale. Perhaps it is the shape. Perhaps it is the way the light falls on the rings at dawn and dusk, turning the desert into something that feels designed. Geologists keep working. They measure the layers. They date the stones. They sketch the slow story of how a dome of rock rose and fell. And in the quiet between their findings, the imagination keeps its own watch, drawn again and again to the same wide circle, asking the same old question. The light moves across the rings, the shadows lengthen, the desert says nothing back, and the wandering, gentle and unhurried, goes on. The desert has its own soft music, and the eye of the Sahara has been listening to it for a very long time, long before satellites looked down from above, long before geologists arrived with their hammers and notebooks. People walked across these rings. They did not call the structure by any name we know today. They simply lived among its pale ridges, its quartzite spines, its wide flat circles of stone. Their voices, their footsteps, the bells of their animals, all of these sounds passed across the rings and faded into the dry air. The Sahara is one of the quietest places on Earth. The wind moves over the sand with a sound that is hard to describe. Sometimes it is a low hush, like breath drawn through cloth. Sometimes it is a higher hiss when the grains slide against each other in thin streams. On the rocky parts of the eye, the wind makes a different sound, a soft scraping, almost a whisper, as it slips along the broken stone. Stand in the middle of the structure on a still afternoon, and you can hear your own heartbeat in your ears. For thousands of years, nomadic peoples have crossed this part of Mauritania. The most well-known today are the Sahrawi and the Moors, herders and traders who guide camels along old, remembered paths. The sound of a camel caravan is one of the oldest sounds in this part of the world. The deep, slow breath of the animals, the soft pad of their wide feet on the sand, the creak of saddles, and the gentle clink of small bells. These sounds have crossed the rings of the eye for longer than any written record we have. Researchers wonder what these travelers thought of the strange ground beneath their feet. From within the rings, the structure does not look like a perfect circle. It looks like a wide, gentle hollow, surrounded by low cliffs of stone. The rings rise as ridges, then dip into shallow valleys, then rise again. To someone on foot or on camelback, the geometry is hidden. You feel the rise and fall, but you cannot see the whole shape. The pattern only becomes clear from far above. Still, the older inhabitants knew this land in a way no satellite ever could. They knew which ridges held shade in the afternoon. They knew where small pools of water might gather after rare rains. They knew the sound of stones underfoot, the dull thud of soft sandstone, the bright ring of harder quartzite. Some researchers believe these audible clues helped guide travelers, the same way a sailor learns the sound of different waters. The question of how deeply the rings shaped local knowledge remains open, because much of that knowledge was passed by voice, not by writing. There is also the sound of silence itself. At night, in the heart of the structure, the desert grows so quiet that the air seems to hum. Some visitors describe a faint ringing in their ears, which is simply the brain searching for sound that isn't there. The stars come out in numbers that city dwellers rarely see. The temperature drops quickly. The stones, warmed all day by the sun, release their heat in tiny cracks and pops, like a slow language spoken by the ground. Geologists who camp inside the eye describe these night sounds with a kind of quiet affection, the small ticking of cooling rock, the distant call of a desert fox, the flutter of an owl moving across the rings, Once in a while, the wind picks up and carries the sand in long, sighing breaths across the open ground. None of this tells us how the rings were formed. None of this answers the central question. But it reminds us that the eye is not only a puzzle on a map, it is a living place with its own soundscape, its own pulse. There are old stories from the region, fragments passed down by herders and travelers, that speak of strange places in the desert where the ground feels different. Researchers are careful here. Few of these stories can be tied directly to the Risat structure, and the ones that can are difficult to date. The question of whether the rings held any special meaning to earlier peoples is still unsettled. Some scholars suspect they did. Others see no clear evidence either way. The silence of the desert keeps its own counsel. So the sound of the eye, in the end, is not a single sound. It is the wind, the camels, the cooling stones, the soft tread of feet that came and went over centuries. And underneath all of it, an older question waits patiently, asking how this circle came to be. Long before satellites looked down at the rings, people walked across them. They left things behind, small things, easy to miss in a place this huge. Stone tools, chipped and shaped by patient hands, scattered across the gravel between the ridges of quartzite. When archaeologists began to walk these slopes carefully, they found numbers worth pausing over. Thousands of tools, tens of thousands by some counts, spread across the rings in patterns that still raise quiet questions about who made them and when and why here. The shapes of these tools tell a kind of story written in geometry. A hand axe is not a random rock. It is a piece of stone struck again and again at careful angles until two faces meet in a sharp edge. The makers understood, in their bones, how stone breaks. They knew that a flake will leave at a certain angle if the blow lands just so. That knowledge is mathematics of a sort. It is the math of force and fracture, passed from one pair of hands to another, across thousands of years. The tools found near the eye span a long stretch of time. Some belong to the Acheulean tradition, which is very old indeed, reaching back hundreds of thousands of years. Others are younger, finer, smaller, made by people who lived during the wetter centuries when the Sahara held lakes and grass. The numbers here are humbling. If you imagine each tool as a single afternoon of work, the rings hold many lifetimes of quiet labor, hands shaping stone in the shade of a vanished tree, children watching. The same gestures, repeated and repeated, while the rings themselves eroded grain by grain in the background. What draws the eye is how evenly the tools are spread. They are not piled in one camp, they are scattered across the structure, in ways that suggest people moved through it freely, perhaps following game, perhaps following water. Some researchers have wondered whether the rings themselves shaped the routes people walked. A ridge of harder rock makes a natural path. A hollow between ridges holds shade, and sometimes a little moisture. The geometry of the place may have guided footsteps without anyone noticing they were being guided. Other researchers are more cautious. They point out that the Sahara, when it was green, was rich in tools almost everywhere. People lived across the whole region. The eye may simply preserve what once covered a wider land. Erosion has stripped away the soft sediment that buried tools elsewhere, leaving the harder stones exposed on the surface. So the apparent abundance here may say more about preservation than about ancient preference. Both views sit on the table. Neither has been fully proven. There is a quiet beauty in the ratios that appear in well-made tools. A symmetrical hand axe has two faces that mirror each other closely. Its length and width often follow a steady proportion, repeated across tools made far apart in space and time. No one taught these makers a formula. The proportions emerged from the work itself, from the way a stone fits a hand, from the way a cutting edge performs best when its angles are balanced. The math was in the doing. The same can be said of the rings above them. The eye's near circular geometry is also a kind of natural mathematics. Layers of rock, eroding at slightly different rates, settle into concentric bands the way ripples settle on a pond. The pattern is not designed. It emerges from simple rules acting over enormous spans of time. Soft rock wears faster. Hard rock wears slower. Repeat for 100 million years, and you get rings you can see from orbit. What we do not know is whether the people who left tools here understood, even dimly, that they were standing inside a giant pattern. From the ground, the rings are not obvious. A person walking the slopes would feel only gentle rises and falls, ridges of pale stone, hollows of darker gravel. The full shape is hidden in plain sight, too large to see without rising into the sky. So, the makers of the tools likely never knew. They moved through the geometry without seeing it, the way fish move through currents without naming them. That thought has a quiet weight to it. Many lives lived inside a shape they could not perceive. Many hands, shaping smaller shapes inside a larger one. The numbers stack up gently. Thousands of tools, hundreds of thousands of years, a few dozen kilometers across, one ring inside another, all of it sitting now under the same patient sun, waiting to be counted, waiting to be wondered about, slowly giving up its quiet arithmetic to anyone willing to look. Imagine standing on the desert floor at the edge of the Richat structure. The sand is pale and warm beneath your feet. The wind moves in long, slow breaths. You can see a low ridge of rock curving gently away into the distance, but you cannot see the circle. You cannot see the rings. From here, on the ground, the great eye is invisible. This is the strange truth of mapping the Richat from below. The formation is so wide that it hides itself in plain sight. A person walking across it would feel only small rises and dips, a few stony ledges, a long flat plain. The pattern that astronauts can read in a single glance is, for someone standing inside it, almost impossible to sense. Early geologists faced this exact problem. Before satellites, before aerial photography, the only way to study the structure was to walk it, stone by stone. They carried notebooks and compasses. They tapped at the rock with small hammers. They marked the layers they found. And slowly, over many seasons, they pieced together a map of something they could not see all at once. The work was painstaking. Each ridge had to be traced on foot. Each shift in rock type had to be recorded. Each small change in the angle of the layers had to be measured with care. The early maps were beautiful, but incomplete. Sketches drawn from 1,000 small observations, stitched together by patient hands. What those mappers were really doing was reading the bones of the land. They followed the harder ridges of quartzite, that pale, glassy rock that resists wind better than the softer stone around it. They noted the gentler troughs between, where the wind had carved deeper over time. They wrote down the colors and the grain sizes. They sampled the strange carbonate rock at the center, the rock that still puzzles researchers today. The balance of forces that shape this place is delicate in its own quiet way. A slightly different climate, a slightly different rate of erosion, and the rings might never have emerged at all. The pattern depends on a careful match between the hardness of the layers and the patience of the wind. If the Sahara had stayed green, the rings might still be buried under soil and root and river mud. The structure might be visible only as a faint dome beneath a forest. It is the dryness, the bare exposure, the long, slow scouring of wind across naked stone that has revealed the geometry to us at all. And if the wind blew a little harder or a little softer, the picture might look different too. Stronger winds might have flattened the ridges, gentler winds might have left the layers smoothed over with dust. The Richat sits in a narrow band of conditions where erosion has done just enough work to expose the pattern, but not so much that it has worn the pattern away. The same is true of the rock itself. Each layer had to be the right hardness, in the right order, at the right depth, for the rings to form as they have, a slightly softer quartzite, and the ridges would have collapsed. A slightly different chemistry in the central rock, and the bullseye might not stand out at all. The formation is, in a sense, a long, quiet accident of fit between stone and sky. Modern mapping now combines the old foot surveys with satellite images, radar scans, and drone photography. Researchers walk the same ridges that early geologists walked, but they carry instruments that can measure tiny shifts in elevation, tiny changes in magnetism, tiny traces of chemistry in the rock. Each new tool adds a layer to the map. Each layer adds a small piece to the riddle. Yet, even now, walking the rings in person feels like walking through an idea too large to hold. You can stand at the center and look outward, and the world looks ordinary. Low hills, distant haze, a few dry stream beds. The pattern only exists when you rise above it, when you climb high enough that the desert becomes a page and the rings become a drawing. This is part of what makes the structure so hard to study. It is too big to see and too quiet to feel. Researchers must trust the satellites to tell them what is there, then trust their feet to tell them what it is made of. The two views rarely line up perfectly. Each ground survey brings small surprises that the orbital images missed. And so the mapping goes on, gently, slowly, one ridge at a time, in a place where the whole pattern hides itself the moment you step inside it. Even now, with all the eyes we have placed in orbit, with all the maps we have drawn and the rocks we have carried home in canvas bags, the eye of the Sahara keeps most of its secrets. The satellites can show us its shape from above. They can measure its width to the meter. They can read the warmth of its stones at noon and at midnight. And yet, when we ask the simplest question, how exactly did this happen? The answer slips through our fingers like fine desert sand. The first great gap is the question of timing. We know the rocks at the center are very old, more than 2 billion years in some places. We know the outer rings are younger. But the act of doming, the slow lifting, and the slow erosion that carved the rings sits inside a window that may be hundreds of millions of years wide. Researchers cannot yet pin down the precise moment when the bulge rose, the moment when it stopped rising, or the moment when wind and water began the long work of stripping it down. The clocks in the rocks tick, but not always in agreement. The second gap lives in the chemistry. At the heart of the structure, in those rings nearest the middle, geologists have found unusual stones. There is a kind of rock called a carbonatite, made mostly of carbonate minerals, which usually points to deep volcanic plumbing. There are pockets of hydrothermal alteration, places where hot fluids once moved through cracks and changed the minerals they touched. These hints suggest that something warm once stirred beneath this patch of crust. But how much heat, and for how long, and from how deep? These numbers remain blurry. The plumbing system, if it ever existed, is long gone. The third gap is the geometry itself. Most domes on Earth are not round. They are oval, lopsided, pulled into shapes by the rocks around them and the forces that lifted them. The Richat is almost a perfect circle. with rings nested inside rings like ripples frozen in stone. Why this particular spot in the crust produced such symmetry is still unclear. Some scientists think the rock layers here were unusually even, lying flat in neat sheets that eroded at neat rates. Others wonder if the upward push came from a single, narrow column of force, like a finger pressing up from below. The evidence does not yet settle the matter. The satellites also cannot see what lies beneath the deepest visible layer. Radar can peer a short way into dry sand. Gravity surveys can sense dense and light rocks far down. But the true plumbing of the structure, if it has any, would sit kilometers below the surface. To read it, we would need long boreholes, drilled in carefully chosen places, sampling the cores meter by meter. Such work is slow, expensive, and difficult in a remote desert. So far, only a few deep samples exist, and they tell only fragments of the story. There is also the human gap. Stone tools sit on the ring slopes, hand axes weather in the wind. We know people lived here, walked here, made things here, when the climate was kinder. But we do not know how they thought of this place. Did they notice the rings at all from the ground, where the curves are too wide to see whole? Did they treat the spot as ordinary or as special? No carvings, no clear monuments, no written word survives to tell us. Their inner life around the eye is a quiet blank. The most interesting gap may be the one between disciplines. Geologists work with maps and minerals. Archaeologists work with bones and tools. Climate scientists work with pollen and lake beds. Each field holds a piece of the puzzle, and the pieces do not yet fit into one clean picture. A full account of the Richat would need to weave deep time, slow erosion, ancient rivers, vanished forests, and human footprints into a single thread. That thread has not yet been spun. What stays open then is almost everything that matters: the exact birth, the exact chemistry, the exact reason for the rings, the exact relationship between the place and the people who once crossed it. The satellites give us a beautiful portrait, sharp and steady from above. But a portrait is not an explanation. The eye looks up at us, and we look down at it, and between us lies a quiet, patient distance that science has not yet closed. There is comfort in that gap. It means there are still discoveries waiting in the sand, still papers unwritten, still questions worthy of a long, slow look. The eye of the Sahara is not entirely alone on this planet. Around the world, in quiet corners of deserts and shield rocks and ancient plateaus, geologists have mapped other circular features that share something of its character. None match it exactly, none have its scale and clarity and near-perfect set of nested rings. But the family resemblances are real, and they offer small clues about how such shapes can come to be. In the deserts of Algeria and Libya, satellite surveys have revealed other ring-like structures pressed into the sandstone. Some are true impact craters, made when a stone from the sky struck the ground and pushed the rock upward in a circular wave. Others are domes worn flat by wind and water, leaving rings of harder layers behind. The dome of Brent in Canada, the ring of Redfort in South Africa, the soft circular eye of Spider in Australia. Each tells a different version of the same simple grammar. A round shape in the rock, a slow unveiling by erosion, a landscape that took 100 million years to finish carving. Studying these cousins helps researchers think about what the eye might be and what it might not. When a feature looks similar from above, but formed by a different process underneath, it teaches a quiet lesson. Geometry alone cannot answer the question. You must walk the ground, sample the stones, measure the minerals, and ask what the rock remembers. Now imagine the planet 1,000,000 years from now. The Sahara will not be a desert forever. The slow wobble of Earth's axis, the long pulse called precession, will once again tilt the northern summers toward more rainfall. Monsoons will creep north, grasses will return. Lakes will refill in places that today hold only dry hollows. The eye will sit beneath a green plain, perhaps, with shallow rivers winding around its outermost ring. The rock will still be there. The shape will still be there. The setting will look completely different. Push the clock further forward in 10,000,000 years. Erosion will have shaved another thin layer from the surface. The exact rings we see today will be slightly altered. New harder bands will be exposed. The center may sink a little or widen, depending on how the underlying layers wear away. The eye will still be recognizable, but it will not be quite the same eye. It will be its own descendant. 100,000,000 years from now, the continents themselves will have shifted. Africa is slowly drifting northward, pressing against Europe. The Mediterranean is closing. New mountains will rise where there is now sea. The piece of crust holding the Richat structure will move with the rest of the African plate, carried slowly toward a different latitude, a different climate, a different sky. Whether the rings will survive that long depends on the patient mathematics of erosion. Some researchers think the structure may already be most of the way through its visible life. Others think the deeper layers could keep revealing themselves for tens of millions of years yet. Push further still into the deep future of the planet. 8 billion years from now, the sun will be hotter and brighter. Earth's surface will be warmer. The continents will have rearranged into new configurations no map can predict with certainty. Whether any trace of the eye will remain is an open question. Erosion may have erased it. Tectonic forces may have buried it, or some quiet patch of desert on a continent not yet named may still hold a faint round ghost of concentric rings. And then there is the other direction the future can run. New circular features are surely forming somewhere right now, hidden beneath ice or sediment or jungle, waiting for some distant generation to uncover them. Domes are still rising in slow places. Impact craters still occasionally appear. Hot fluids still rise through cracks in old rock and leave behind strange mineral signatures. The planet is not finished making circles. It never will be. For the people who study the eye today, the future of the question matters as much as the answer. Better satellites will come. Better ground-penetrating tools. Better ways to date small grains of rock. Each new generation of instruments may bring the central mystery closer to resolution, or open new puzzles that no one has thought to ask yet. The structure will not run out of things to teach. It is too large, too layered, too patient for that. So the eye sits in its quiet desert, surrounded by its scattered cousins on other continents, waiting. The wind moves across it tonight, as it has for a very long time. And somewhere in the long arithmetic of geology, the next chapter of its story is already being written, one grain of sand at a time. Let us step back now, all the way back, and look at the eye of the Sahara as one small detail in a much larger picture. We have spent these long hours circling its rings, weighing its theories, sitting with its puzzles, and still the question of how it formed remains open. So let us hold that openness gently and place it inside the wider story of the Earth itself. The rocks at the center of the Richat structure are very old. Some of them formed more than 2 billion years ago, long before the first animals crawled across any shore. To stand at the middle of those rings is to stand on stone that watched the early Earth take shape. The atoms in that stone are older still. They were forged inside ancient stars that lived and died before our sun was even a cloud of gas. When those stars ended, they scattered their atoms across the dark. Some of those atoms drifted, joined, settled, and slowly became the desert floor of Mauritania. The iron that gives certain ring layers their rusty color was born in the heart of a dying star. The silicon in the pale quartzite came from the same kind of cosmic furnace. Even the carbon in the small bones of ancient fish, scattered across that desert from a time when seas covered the land, was made in stars that no longer exist. The eye is not separate from the sky above it. It is made of the sky. Every grain of sand around it carries the memory of stellar fire. This is true of us as well. The calcium in our bones, the iron in our blood, the oxygen in every breath we take tonight. All of it was cooked inside stars. We share that heritage with the rings in the desert. When a person stands at the center of the Richat structure and looks out at the layered stone, they are, in a quiet way, looking at a cousin, a very still, very patient cousin, made of the same star stuff, arranged in a different shape, holding a different kind of secret. The competing theories we have visited across these hours all sit on the table together. The slow dome that rose and fell, the hot fluids that moved through the cracks, the careful work of wind and water across millions of years. Maybe one of them is closest to the truth. Maybe the answer is a quiet braid of all of them. Maybe there is a piece we have not yet imagined. The earth keeps many of its old notes in a language we are still learning to read. There is something soft and steadying in that thought. We live on a planet that has been writing for 4.5 billion years, and we have only been reading for a few centuries. The eye of the Sahara is one paragraph in a very long book. So is the deep ocean. So is the slow drift of the continents. So are the bones in your hand and the breath in your chest. Everything connects to everything, across scales we can barely hold in our minds. It is easy sometimes to feel small in the face of all this, but smallness is not the right word. A better word might be belonging. The rings in the desert belong to the earth. The earth belongs to a long line of stars. The stars belong to the deep, slow turning of the universe, and we belong to all of it, made of the same atoms, breathing the same air that has cycled through forests and oceans for billions of years. Tonight, somewhere over Mauritania, the desert is cooling under a vast, dark sky. The rings are quiet. Wind moves softly across the pale ridges. No one is asking the rocks for answers. The stars wheel overhead, the same stars whose ancestors gave the rings their atoms, and the night settles in the way it has settled, for ages without count. The mystery is still there, patient, in no hurry to be solved. And here you are, far from that desert, settling into your own quiet night. The same calcium in those ancient sea bones is in your bones. The same iron is in your blood. The breath, leaving you now, will, in time, drift across continents, perhaps even across the Sahara itself. You are part of the long sentence the earth is still writing. So is the eye. So is every unresolved question we have held tonight. That is enough. To wonder is enough. To know that the earth still keeps a few secrets is enough. The rings have waited a long time, and they can wait a little longer while you rest. The desert holds its quiet now. Far above the dunes of Mauritania, the night sky turns slowly, soft and patient, the way it has turned for billions of years. And down on the ground, the great rings of the Richat structure rest in cool darkness. The wind moves across them in long, easy breaths. Grains of sand shift by the width of a fingernail. The stone waits as it has waited for the morning that is still many hours away. We have spent this long evening walking around a single question, a vast circle in the desert, almost too round to be natural, almost too natural to be anything else. We looked at it from orbit, where it shines like a pale eye on the skin of the planet. We walked among its layered ridges in our imaginations. We listened to geologists trade theories like quiet card players, each holding good cards, none quite winning the hand, and we let the question stay open, because it is open, and because there is a soft pleasure in not knowing. One school of thought says a dome of rock pushed up from below and slowly wore away in even circles. Another says hot fluids moved through the layers and shaped them from within. Some wonder about ancient impacts, though the evidence for that has mostly fallen aside. A few imagine older stories layered into the rings, stories of green rivers and people who once camped beside them. None of these ideas has fully won. All of them deserve to be carried gently in the mind, like small stones in a pocket. And maybe that is the right way to end, not with a verdict, not with a tidy answer tied in a ribbon, just with the soft acknowledgement that the earth keeps some of its writing in a script we have not finished learning. The rings will still be there tomorrow. They will still be there next year, and in 1,000 years, and in 100,000. They are in no hurry. They do not need us to solve them. Picture, for a moment, the planet from far away, a blue and white marble, turning at its own slow pace. The Sahara is a wide pale band along one curve of it, and somewhere in that band, a single faint circle catches the early light. Around the planet, oceans rest under the moon, silver and dark and endlessly patient. Forests breathe in the night, glaciers creak softly in their long sleep. A whale, somewhere in the deep, sings a low note that no one will ever record. The earth is doing what it has always done. It is being itself, quietly, with no audience required. You're part of that quiet. Your breath, slow now, is part of the same air that moves across the rings in Mauritania. The warmth of your body is part of the same warmth that holds the planet alive. You are small, and the world is vast. And that is not a frightening thing. It is a gentle thing, a safe thing. You can let the mystery of the great circle stay just as it is, unresolved and beautiful, and you can let yourself rest beside it. There will be more questions tomorrow. The earth has so many. Caves no one has fully mapped, trenches in the seafloor where the light has never reached, stones placed in patterns by hands long gone, currents that move in ways we are only beginning to understand. We will sit with another of those questions on another night, and we will wander together, slowly, the way humans have always wandered. For now, though, the rings can fade from your mind, the desert can grow soft and far away, the sound of the wind can blur into the sound of your own breathing, your shoulders can settle, your jaw can loosen, your hands can grow warm and heavy. The day you carried is no longer yours to hold. You can set it down. The night has it now. Somewhere on the other side of the world, the sun is rising over an ocean. Somewhere else, snow is falling without sound onto a forest of dark pines. Somewhere, a small river is finding its way around a stone it has been working on for 1,000 years. The earth is busy with its slow, gentle work, and it asks nothing of you tonight except that you rest. So rest. Let the great circle keep its secret. Let the planet keep turning. Let the long, kind dark settle over you like a soft blanket pulled up to the shoulder. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.